Okay, so have you all found the voltage here? That's 3 volt using the potential divider. Now we have a battery on the other side. So I have found the potential on one of the terminals of this voltmeter. Now I have to find the potential on the other terminal of the voltmeter. So here we have a battery. So I can draw this potential increase using this arrow. So here it's 0. There's a potential increase of 4 volts. So here the potential is 4 volt. Then the difference between the terminals, difference between terminal is 1 volt, is 1 volt. Therefore reading of V is 1 volt. Is it clear how we did this question? Here for these arrows are not only for batteries. Okay, we can use them for these resistors also. So here it is the arrows will be like this. So here it's 9 volt. So when you check the current flow, it's like this, right? So if you are moving in this direction, look, here you have a 12 volt of increase. Here it drops by 9 volt, and across this resistor it drops by 3 volt. Okay, so I hope that convention is clear using these arrows. If we use double head arrow, that means potential difference. So if I use like this, it says this is the potential difference across this resistor. If I have only a single head arrow, that means it shows in which direction the potential is going to drop. Okay? Is it clear? Those arrows. Rahama and Saja. Okay. Saja, how about you? Okay. So let's quickly try these questions in the past paper. Under combination of cells, try 2, 4, 7, 8, 9, 10 and 23 under combination of cells, and in potentiometer 1, 3 and 14. One more minute. Before we go to these questions, we have 2 more examples to discuss. Let it be there. We have 2 more examples. Example 6. We want to find the terminal voltage of a battery of 6 volt. Of 6 volt. Now there's a current flow in this battery of 2 ampere, and the internal resistance R is equal to 0.5. So this is identical. Now this setup is identical to ideal battery with a resistor connected in series, 0.5. So if the current is flowing in this direction, we will have a potential drop in the opposite direction, right? And here, this battery will have a potential increase like this. So we have to find what is the potential difference between these two terminals. What is the potential difference between these two terminals? So here, what will be the potential drop? V equal IR. So this is 1 volt. So if you start from this side, let's start from this side. I'll consider this one as 0 volt. Then 6 volt increase, 1 volt increase. Therefore here it's 7. So V is equal to 7. Is it clear how I got this? Saja and Shahama. Sarah, can you try for the next one? Example 7. How about Saja and Shahama? Is it clear, this question? Okay. Those who are okay with this, leave some space, leave around 3 lines and try the next. Those who are not clear, I will explain once. Find the terminal voltage. So Saja, here we have a simple equation. I will tell about that equation. Before that, we have to understand what is happening. Okay. Now the current is flowing in this opposite direction to the battery. So now what I'm going to do is, first I am going to mark the potential increase or potential drops. So this is a battery. This will always increase the potential in this direction. So I have marked the arrow in the direction of the battery. Okay. Next, we have a resistor. In this resistor, the current is flowing in this direction. So if current is flowing in this direction, there will be a potential drop in this direction, right? Can I show that one as a potential increase in the opposite direction? Did you get my idea? Because current is flowing in this direction, there will be a potential drop. What I'm going to do is, I am going to show it as a potential increase in the opposite direction. Both of them have the same idea, right? Is it clear, Saja? So, I have marked it as 1 volt. I found it using V equal IR and marked it as 1 volt. We have to find the potential difference between these 2 points. So potential difference doesn't bother about the signs. We have to just get the difference, right? So I assumed this point to be 0 volt. So I started from here, 0, here it's 6, here it's 7. So the potential difference between these 2 points is 7. Clear? Try the next. Yes, Sarah, it's fed. Shahama, have you got it? Saja? So can you remember we got an equation? We got an equation for terminal voltage. V is equal E minus IR. So here V is equal, what is E? That's 8 volt minus 1.5 into 2. So that is 3. Then 8 minus 3, that is 5. So here what is happening when the current is in the direction of battery, then the potential increases due to the battery. Again, the potential drops across the internal resistance. Okay, so when current is in the same direction, this will be our equation. V is equal E minus IR. But if current is in the opposite direction, if it is in the opposite direction, the equation becomes V is equal E plus IR. So E is equal to 6, I is 2, 0.5, so that is 7 volts. Okay, so is it clear the difference between these two equations? It depends on the direction of current. Clear? So Saja and Shahama, okay? Shahama, okay. So now let's try these questions. 2, 4, 7. So question number 2 is a statement-based question. Yeah, we have a 9-volt battery. We have a 9-volt battery with internal resistance of 10 ohm. So statement A says that the cell cannot be used to obtain current greater than 0.9 amperes. So when can we get the maximum current out of this battery? When we short circuit this. So when we short circuit, V is equal IR. So V is 9, R is 10. When we short circuit, let's mention it. Maximum current when short circuit. Maximum current when short circuit. So if we short circuit 9 volt, R is equal to 10. So let's find the current. I is equal to 0.9. So what can you tell about statement 1? So this wire also will have some resistance, right? Therefore, let's assume resistance is equal to 0. Then actually I is less than 0.9. So what can you tell about statement 1? Statement 1 is correct because we cannot produce current greater than 0.9. Think about statement B and statement C. What can you tell about statement B? It will produce a potential difference less than 4.5 across a resistor having a resistance greater than 10 when it is connected across the terminal circuit. It's correct or wrong? We can consider the internal resistance as an external resistor. Now let's connect 10 ohm resistor. If we connect 10 ohm resistor, this is 9 volt, this is 10 ohm, this is an external circuit, external resistor. Let's say that's a variable where R is equal to 10. Now here in this circuit, the potential difference across this will be 4.5 and current I is not equal to 0. Okay. What if I increase this R? If R is increased, if R is greater than 10, then V is greater than 4.5. Is it clear? Is this statement clear? If R is greater than 10, then V is also greater than 4.5 because it is just like a potential divider circuit, right? We have in a potential divider circuit, V is proportional to R. Is it clear? Are you all clear? This is a potential divider, and in a potential divider, V is proportional to R. So if we increase the resistance, resistance will increase. Okay. Therefore, statement B is wrong. How about statement C? when the terminal voltage will be equal to 9 volts. Terminal voltage will be 9 volts only if I is equal to 0. V is equal to 9 volt only if I equals 0, right? So C is correct. Then the answer is A and C, third. Is everyone clear? Sarah and Shahama. Right, question number 4. So there, what can you tell about statement A? Shahama, for question number 4, yeah, telling A and C. Now let's say we have a cell with internal EMF E and internal resistance R. Now, if I short circuit, E is equal I into R, where I is equal E over R. Therefore, current is finite. Therefore, I is finite. Then A is wrong, right? Statement B. When we have the ideal, in ideal, this is E, and I have a resistor connected. Because a resistor is connected, there is some current I. I is not equal to 0. So here, still, V is equal to E. Terminal voltage V is equal to E for ideal. But if we consider the real case, this is R, this is E, because it is connected, because there is a closed circuit or a closed loop, I is not equal to 0. Now, this time, we have internal resistance R. We have internal resistance R. So, if we calculate the terminal voltage V is equal to E minus IR. So I'll consider this one as V1 and this one as V2. So this is the practical cell. So V1 not equal to V2. Therefore, statement B is wrong. Okay, statement B is wrong. And let's look at statement C. Sham, let's come back. Statement C, one of the cell gets heated up when a large current is drawn from it. It is correct, right? The practical cell gets heated up. The practical cell heats up due to heat dissipated from internal resistance. From internal resistance. Shahama, here, if the internal resistance is 0, then we get I over 0 infinity. Okay, so it is not actually defined. It doesn't have a proper definition. So in that statement, they say both cells. Because they mention both cells, if at least one of the cell is finite, then the statement is wrong, right? That is why we said statement A is wrong. Statement C is correct. So only C. Is everyone okay? Try question number 7. Question number 7. Have you all got the answer? If this is looking a bit complex, you can just turn this over. You can just turn this over like this. What do you all say? So it is identical to AB. So across AB, we have these two these two cells in parallel. The equivalent of this is E. Then E and this E is in series. Therefore, this is equivalent to 2E. Fourth answer. I see it clear that it's 2E. These two together parallel, therefore it's E, and that E with this E is in series. So you have to add. 3 of you clear. Shahama, try question 8. Done. Okay, there we have to find which answer, in which answer uh, it doesn't show that this 1.5 volts dry cell doesn't have an does have an internal resistance. The question is like this: you have to find from 5 occasions which occasion doesn't show that the cell has an internal resistance. Okay, so of the 5 statements, 4 statements will show that the battery has internal resistance. So let's try to find out them. Okay, we are trying to find out which proves that the battery has an internal resistance. Okay, let's find out which statements show the battery has internal resistance. The battery has internal resistance. So let's look at statement 1. In statement 1, they say terminal voltage vary with the resistance connected with external resistance R. So this one shows, right? This one is correct. Why? Now we have a battery with an internal resistance. We have a battery with an internal resistance R, and I have an external resistor capital R. If I change capital R, I changes. I changes. Therefore, so R change. If R change, I changes. Therefore, V changes. Is that clear? Now let's look at statement 2. So statement 2, what can you tell? When we connect similar cells in series, we know that the equivalent will be E over R by 2. So terminal voltage. Now, when I compare the terminal voltage of this with this, so here it's V1, here this is V2, this is V2, V1 will be less than V2, right? Is it clear? Saja and Shahama, is it clear? Saja, how about you? Statement 3. What can you tell about statement 3? In statement 3, terminal voltage depend on the internal resistance of voltmeter used. So this is also similar to 1, right? So it is just like having an external resistor. If you change, I change, and then we change. So that is also similar to the first one. So that also shows that it has internal resistance. Fourth, the cell becomes warm when its terminals are short-circuited. So that is also correct. Fifth one, terminal voltage measured with an ideal voltmeter shown 1.5. So now here this is true, or this is possible. This is possible for both cells. For both cells with internal resistance, or without internal resistance, or when R is equal to 0. Why? Since I equals 0 for ideal voltmeter, then the answer has to be fifth. Clear? So here the fifth one, in fifth one you cannot find out whether it has internal resistance or it doesn't have. So all the other four clearly shows it has. So the fifth one has to be the answer. Is four of you clear? Whether they have internal resistance or not?